today I will show you a very cool demo of how we can support a single token existing natively on both chairs of Neon and Solana without the need of always bridging when you have to interact with a contract from the other chain. But first, 2 or 3 words about what is new EVM, what are we doing. So basically, new EVM is providing a solution which is combining the adoption of Ethereum tools and Solana's fast and cheap transactions. So new EVM is not a sidechain or a layer 2 protocol. It's actually much simpler. It's a smart contract living inside Solana. So basically, how we managed to support the entire EVM inside Solana? Well, basically because Solana allow us to store a bit more executable data compared to Ethereum. I think it's somewhere around 10 megabytes, which is pretty much enough to store the entire EVM. Basically, we call it Neon Proxy, but it's basically Ethereum-like RPC, which is listening for Ethereum-like transactions. And basically what happens is when such transaction appears, our Neon Proxy unwraps it and wraps it again as a Solana-like transaction. And because we rely on Solana, beside the fast and cheap transactions, we also benefit from the parallel execution of the transactions, and which means that all of the transactions run on Neon EVM are basically getting executed in a parallel way instead of sequential way. And this is also happening because Neon is stateless, which means that the contracts on this is also happening because the contracts on Solana is stateless because they do not hold any state, but they hold only their executable bytecode. One more thing to mention is that we also support the majority of opcodes. Next thing, so we basically Neon EVM is a very easy way to use your Ethereum stack and use it to deploy on Solana. You can use pretty much all of your most famous Ethereum stack like Foundry, like Hardhat, like Solidity, Viper, even the most famous wallets such as MetaMask, Wallet Connect to basically deploy on Solana, which is pretty cool because me personally, as a Solidity developer, I don't have to change my stack at all to deploy on Solana and benefit from the fast and cheap transactions. Now going back to my demo today, I will be showing you a standard of ours, which is called ERC20 for SPL. This is like the first use case of how we can support Neon contracts interacting with Solana natively. So first, we will be using a Hardhat, one of the most widely used frameworks for deploying on Ethereum. In Hardhat config, we have defined 2 networks, which is first the Neon DevNet, the second one is the Neon mainnet, and for the demo, we will be using the DevNet one. Now going to walk through the contract. As you can see at the top, we have defined basically using two libraries out of the OpenZeppelin package. This is pretty cool because just the other day I saw some random developer on the Solana forums asking, is there something like OpenZeppelin but on Solana? And of course there isn't currently, but this is an option now how to basically use OpenZeppelin and deploy on Solana. The next 2 more interesting stuff are these 2 interfaces. So basically, what is a SPO token? SPO token is the equivalence of ERC, but on Solana. It's a bit more different because currently in Ethereum, we have a different set of standards like ERC20, ERC721, and so on. But in Solana, it's a bit more centralized when it comes to this because there is like one central registry. And this central registry is the protocols of SPO token, which is used to deploy basically any token on Solana. So yeah, that's pretty much for SPO token. As you can see here on this line, we are creating the interface for the SPO token registry. And this Metaplex right here is basically a set of protocols which you use on Solana. For example, when you deploy a new token on Solana, basically use Metaplex to attach some metadata to it, such as a token name, token symbol. For NFTs, you can use also royalties, fees, and so on. And going down to the contract, you can see that we support pretty much the ERC20 interface. We have name, symbol, decimals, balance of transfer form, but I want to pay more attention to these two methods. So basically, approve Solana and transfer Solana are pretty much the same thing as transfer or approve in ERC, but the only difference is that this will be used in the case where the receiver doesn't have a Ethereum-like wallet, but he has a Solana-like one. So basically, you can see that the two parameter right here is not in a type address, but instead is in bytes 32, which is actually the Solana address, and encoding this value into base 58, it will return you the raw public key of Solana. One more method that I want to highlight here is this one, the Solana account. Okay, so one important thing to mention is that when you interact with the contract for the very first time, behind the scenes there is a Solana key pair creation for your Ethereum-like wallet. So, but this is only happening the first time, and this is why the first transaction is a bit more expensive. But once done that, you don't have to do it always. And yeah, I will show you in a bit how is this happening. Going through my deployment script. So the deployment script is very, you can see it's a very basic one. At the top, I have defined 2 users for the demo. This is my deployment script of the ERC20 for SPO. One thing worth mentioning here is that this is the decimals of my contract. So because the end goal here is to deploy on Solana, basically we have to adapt with the Solana limits, and currently you cannot store more than a bigger value than UN64, so you are limited to using 9 decimals. Here, a bit down, I'm minting the first tokens to the owner, minting 1,000 tokens. Then, a bit down, I'm initiating 2 transfers. They're pretty much the same, with the same message sender, with the same receiver, and the same amount, and I will show you why I'm doing this. And at the bottom, I'm just displaying the Ethereum-like and the Solana-like wallet addresses for each one of my users in this demo. Okay, let me just run my deployment script now. As you can see, the command is nothing special. It's just like a usual way of deploying through Hardhat, just with the different network, which is Neon DevNet. Okay, we see that our proxy has been minted. We see at the beginning that nobody of the user has a balance. But by the time of the minting, we have minted 1,000 tokens to our owner. And then after doing the 2 transfers, our owner is left with 800 and the user is left with 200. And these are also the Ethereum-like and the Solana-like addresses for each one of the users. Now, if we check this proxy in our DevNet Neon scan, yeah, we can see the proxy has been deployed successfully. Now, if we scroll down to the transactions, we can see this is the first one, which is the deployment. The second is the minting to the owner, and third and fourth are the transfers from the owner to the user. The first one, here the more interesting stuff is, for this new transaction, we actually have 4 different Solana transactions, and this is happening because what I did mention in the beginning is that we have our Neon proxy, which unwraps and wraps transactions, but there are differences in the limits between Solana and Ethereum-like chains. Basically, if most of you should know that in Ethereum, you don't have like a memory limit of your transaction. You're pretty much limited by the block gas limit. But in Solana, it's a different story. You are limited by a bit more than a kilobyte. So in this scenario, if our Neon proxy has taken this Neon transaction and submitted it as one into Solana, this was going to revert. But because Neon proxy was smart enough to see that, okay, this is not going to work, it split it, the main Ethereum-like transactions into 4 smaller Solana transactions. Now, let's look at the other two transactions. Yeah, this is the minting, as you can see, minting from 0 address to our owner, 1,000 tokens. And the next 2 transactions are the 2 transfers, which are pretty much with the same data. So this is the first transfer, and you can see that the fee currently is 0.26, and for the second transfer, the fee is 0.001. So the difference is more than 200 times, and why is this happening? Let me show. This is because what I have mentioned earlier, behind the scenes for your very first transaction, there is a account creation for your Ethereum-like wallet. So going now to Solana scan and scrolling down to the instructions, we can see that, okay, there was a token transfer with amount of 100 tokens, and this is our source, this is our destination. And if we double check our Solana-like wallet addresses, we can see that the destination is our, the source is our owner, and the user is our destination. But why is this transfer a bit more expensive? Actually, not a bit, but 200 times more expensive than the second transfer, is because this user address has never yet interacted with the Solana contract, and basically the first transaction is like initialization one. As you can see, we have a instruction here, which is initializing the Solana's account for the user. And in the second transaction, you can see that there is no such thing. I mean, once you do it, you don't have to do it twice, and this is why this transaction is 200 times more cheaper. Basically, this is only the token transfer. So yeah, that was pretty much our first use case of how we can have Neon contracts interacting natively with Solana contracts. Another use case would be, okay, for example, in Solana there is a Chainlink deployed with different price feeds and so on, and because it is deployed there, we don't have to deploy it also on Neon. We're basically taking the price feeds directly, natively from Neon to Solana. One last thing before I finish my demo. Guys, we're live on mainnet since this July. We have like a different set of products, like the EVM that I just mentioned, which is a smart contract inside Solana. The proxy server, which is smart enough to unwrap and wraps again transactions. The Tracer API, which is getting a huge update very soon, which is helping developers to debug their stuff. The Neon Pass, which is our native bridge between Neon and Solana. The Neon faucet for sending testing amounts to users on the DevNet so they can play around with their stuff. And the Neon DAO, which is our governance. So yeah, that was pretty much about my demo for today. Please join us, give it a try, and start building your stuff. Thanks, guys. And yeah, thank you. And one more thing to mention is that we have our hackathon today and tomorrow. You can join up and try to win some rewards. The second one is very cool. We would like you to basically destroy our DevNet. We want to see how much it can handle. Yeah. So yeah, any questions so far? Okay, if you have some questions, just find me somewhere here at the event and let's talk, yeah?
So that is the deploy transfer process, right?
Yeah, that was a deploy on Solana through Neon by using Hardhat, yeah?
So what were the
So currently you cannot rely on any of the Ethereum state. We don't rely on that. We only rely on the Solana state. Yeah. Yeah. But basically, you can use any kind of Ethereum stack to deploy. Basically, Neon EVM is like taking your Solidity bytecode and transferring it into Solana.